Reaction between metals and non-metals. Chemical characteristics of metals and non-metals are different because electronic configurations of their atoms are different. Atoms of both have a desire to acquire electronic configuration of nearest noble gas atoms which are quite stable. The elements belonging to noble gas family are helium, denoted by He, neon, denoted by Ne, argon by Ar, krypton, that is Kr, xenon, that is Ze, and radon, that is Rn. The last member is radioactive in nature. If we look at the electronic distribution of elements, we find that the first element, that is helium, has 2 electrons in its only shell, while all others have 8 electrons in their outermost shell, also called valence shell. This means that helium has a complete duplet while the others have a complete octet. Noble gases do not normally react with other elements. They do not even form diatomic molecules. This is unlike gases which exist as diatomic molecules like hydrogen, chlorine, nitrogen and oxygen. This shows that the noble gas atoms have no reactivity to combine with either the noble gas atoms or the atoms of any other element. The complete lack of reactivity of the noble gases is somehow linked with the electronic configurations. Let us have a look at electronic configuration of noble gas elements. Helium has a symbol of He, has an atomic number 2 and electronic configuration of 2 in its first shell. Neon is symbolized as Ne, has an atomic number of 10. Its electronic configuration can be represented as 2,8. Argon, symbolized as Ar, has atomic number of 18. It has electronic configuration of 288. Krypton is symbolized as Kr and has atomic number of 36. Its electronic configuration is 2,8,18,8. Xenon, symbolized as Xe, has atomic number 54. Its electronic configuration is 2,8,18,18,8. Radon is symbolized as Rn. Its atomic number is 86. It has electronic configuration of 2,8,18, 32, 18 and 8. Since the members of the noble gas family have the maximum number of electrons in the valence shells of their atoms that are permissible according to Bohr-Bury rule, these are quite stable. Their atoms do not have any desire to take part in a chemical combination. Let us have a look at the electronic configuration of some metals. Lithium denoted by Li, has an atomic number 3. Its electronic configuration is 2,1. Sodium, which is denoted by Na, has an atomic number 11. Its electronic configuration is 2,8,1. Potassium is denoted by symbol K. It has an atomic number 19 and its electronic configuration is 2,8,8,1. Manganese is denoted by Mn. It has an atomic number of 12. Its electronic configuration is 2,8,2. Calcium is denoted by Ca. Its atomic number is 20. Its electronic configuration is 2,8,8,2. Aluminium is denoted by symbol Al. Its atomic number is 13 and its electronic configuration is 2,8,3. From these electronic configurations, it is quite clear that none of the atoms of the metals have stable electronic configuration like noble gas elements. This means that their atoms do not have either 2 or 8 electrons in their valence shells. However, they have a strong urge or desire to do the same. Metals, which we have discussed right now, can have the configuration of noble gas elements neon or argon if their atoms lose the electrons present in the valence shell. On having a look at the electronic configuration of some of the non-metals, you can see that they have more than 5 electrons in their outermost shell. Nitrogen is denoted by N and has an atomic number 7. Its electronic configuration is 2,5. Oxygen is denoted by symbol O. Its atomic number is 8 and its electronic configuration is 2,6. Fluorine is denoted by the symbol F. Its atomic number is 9 and its electronic configuration is 2,7. Phosphorus, denoted by P, has an atomic number 15 and an electronic configuration of 2,8,5. Sulfur is denoted by S and has an atomic number 16. Its electronic configuration is 2,8,6. Chlorine is denoted by the symbol Cl and has an atomic number 17. Its electronic configuration is 2,8,7. Non-metallic atoms have 5, 6 or 7 electrons in the outermost shells. Non-metals gain electrons to have 8 electrons in their outermost shell and achieve a stable configuration. Metal combine through ionic bonds with non-metals to form ionic compounds. The first bonding theory was proposed by W. Cosell and G. N. Lewis. Electrovalent or ionic bond. An electrovalent or ionic bond is formed by the complete transfer of electrons from one atom to another. Such a transfer results in formation of charged particles or ions. Neutral atoms which have lost electrons will have a net positive charge and are called cations. Formation of cations. In cations, the number of positively charged protons is more than negatively charged electrons. Sodium achieves the noble gas configuration by losing an outermost electron to form a cation. Sodium ion has 8 electrons in its outermost shell, that is L shell. It has achieved the noble gas configuration, so it has become more stable. Since sodium ion has the same number of outermost electrons as neon, it is quite unreactive. But sodium metal is highly reactive. When it is put in water, it burns explosively. But sodium chloride that contains sodium ions simply dissolves in water without any reaction. This means that sodium atom is highly reactive and has the electronic configuration of 2, 8, 1. It becomes unreactive on losing one electron, thereby achieving electronic configuration of 2, 8 and becoming a cation. Let us take example of magnesium. Magnesium metal atom loses 2 outermost electrons to achieve the noble gas configuration and form magnesium 2 positive ions. The number of positive charges indicated on the symbol of the element represents the number of electrons lost. In the formation of magnesium ions, 2 electrons are lost from the outermost shell of the neutral magnesium atom. The magnesium ion has a noble gas configuration. It has now 8 electrons in its outermost shell. The magnesium ion, like the sodium ion, also becomes inactive like the noble gas atoms. Group 2 atoms form tripositive cations from their neutral atoms. For example, formation of aluminium ion from aluminium atom. Aluminium has atomic number 13. It has in its K shell 2, L shell 8 and M shell 3 electrons. When an aluminium ion is formed by the loss of 3 electrons from the outermost shell, the K and L shell contain 2, 8 electrons respectively. This means that aluminium can achieve the noble gas configuration if 3 outermost electrons are lost. When a neutral atom gains 1 or more electrons, it forms negatively charged ions. Negatively charged ions are called anions. Formation of anions. Anions have more number of electrons than the number of protons in their nucleus, with the result that they carry a net negative charge. Atoms of group 17 elements of the periodic table prefer to form anions since they have 7 electrons in their outermost shells. This is one short of noble gas configuration. They may gain 1 electron to form negatively charged anions. Let us take the example of chlorine atom. Its atomic number is 17. It has 17 protons and 17 electrons. The arrangement of 17 electrons in different shells is 2, 8, 7 in K, L and M shells. There is a negative charge on the chloride ion. This indicates that there is an extra electron in the chloride anion in comparison to neutral atom. The electronic configuration almost resembles to noble gas atom. Chlorine is very reactive and can kill germs and make drinking water safe. We will next take the example of oxygen. A neutral oxygen atom, on gaining 2 electrons, forms an oxide ion which has a noble gas configuration. The size of the oxide ion is much bigger as number of protons is only 8 and the number of electrons is 10. It is due to these extra electrons in the oxide ion that its size is large. Activity. Let us try to understand the formation of sodium chloride from sodium metal and chlorine gas. For this, we cut a small piece of sodium metal . A vigorous chemical reaction takes place between the sodium metal and the chlorine gas, during which a white powder, sodium chloride, is formed. In this reaction, one electron is transferred completely from each sodium atom to each chlorine atom, forming sodium ions and chloride ions respectively. The electronic configuration of sodium ion is the same as that of argon. Both sodium ion and chloride ion, like neon and argon, show no further tendency to undergo any chemical reaction. The product, sodium chloride, which is formed due to the electrostatic forces of attraction between oppositely charged ions, sodium and chlorine, has no resemblance with the reactants sodium or chlorine. Sodium is highly reactive and chlorine is highly pungent smelling gas. Sodium chloride is neither metallic nor pungent. The process of electron transfer can be conveniently represented in one of the ways which we will discuss. Alternative method of representation for ionic or electrovalent bonding. Sodium loses an electron to form sodium ion. Chlorine gains an electron to form chloride ion. Sodium ion and chloride ion react to form sodium chloride. Electrostatic forces of attraction exist between sodium ion and chloride ion, leading to the formation of sodium chloride. Another convenient way, as proposed by G. N. Lewis, involves putting dots to represent the valence shell or the outermost shell electrons around the symbols of an element. Such representation is also called as electron dot structures of Lewis structures. Sodium atom is represented by Lewis formula as Na dot. One dot means one electron remains in the outermost shell. Chlorine atom is represented by Lewis formula as shown on screen. 7 dots means 7 electrons are in outermost shell. Formation of an ionic compound can be depicted as shown on screen.